Hi, welcome back. This is Professor Ridge, and today's lesson 6.5, solving applications using rational equations. Now, first we're going to talk about modeling work problems. So I want you to realize that work is just like a distance problem in this regard. You got your rate of your worker, or rate work, times your time working. That's going to give you the amount of work that you completed. So just like distance equals rate times time, the amount of work equals rate times time. So rate times time equals the amount of work you complete instead of distance. So if Joe can complete one job in 4 hours, then how fast does he work? What's his rate? His work rate. And so if we use that formula, rate times time equals the amount of work, he can do one job in 4 hours. And if I solve this for R, to find out what his rate is, you're going to divide both sides by 4, and you get 1/4. So you can complete 1/4 of a job, of a complete job, per hour. All right? So if Susie can complete one job in 3 hours, then what is her work rate? So again, rate times time equals the amount of work. So rate times, she can do one job in 3 hours, so her rate is 1/3 jobs per hour. Now, how fast, if they were to work together, so if Joe and Susie work together, how long will it take them to complete one job? So basically we're going to take their rates. This is Joe does 1/4 job per hour, plus Susie does 1/3 job per hour, so that's their rate working together. Times the amount of time, which we don't know, to complete one job. So now we're going to distribute the t, so t over 4 plus t over 3 equals 1, and we're going to solve for t. Okay. So basically, once you get the hang of this, this is the equation where we're going to start. So you're going to do t for time divided by one person's time, t divided by the other person's time, to complete one job. Okay, so what's the LCD of this? It'd be 12. So we're going to multiply everything by 12. 12t divided by 4 is 3t. 12t, so I'm going to multiply both sides by 12, the LCD. Distribute it. 12t divided by 3 would be 4t. 12 times 1 is 12. And then divide by 7. So t equals 12/7 hours. Okay, so it'll take them a little less than 2 hours working together. All right, so that's pretty much how you do those work problems. We'll try one from the book. Okay, so Brian can finish the floor of an apartment in 8 hours. Carolyn can finish it in 6 hours. And how long will it take them working together? So remember, we're going to do basically this formula, t over the first person, T over the second person equals one job. The job being finishing a floor in this case. So we're going to do T over 8 plus T over 6 equals 1. We're going to multiply everything by the LCD, which is 24. Distribute. 24t divided by 8 is 3t. 24t divided by 6 is 4t. 1 times 24. 3t plus 4t is 7t. And divide by 7. So t is 24/7, or let's see, what would that be? 3 3/7 hours. So not quite 3.5 hours. Okay, so Kent can cut and split a cord of wood twice as fast as Brent can. When they work together, it takes 4 hours. How long does it take them working alone? So remember the formula, T over A plus T over B equals 1. T is equal to the time together. A is Brent's time, the first person's time, which is Brent in this case. Alone. And B is the second person working alone, which in this case is, I don't know, I said that wrong. This one's Kent, and this one's Brent. Alright, so the total time here is, in this case, is going to be 4. So it's going to be 4. And we have this relationship. Kent can cut and split a cord of wood twice as fast as Brent can. So if it takes Kent A hours, then Brent is going to be, so let's see, who's faster? Kent is faster, so it'll take Brent twice as long. So if it takes Kent A, then B is going to be, so if this is A, then Brent is going to be 2A. So that'll be A, 2A. Now I'm going to solve it for A. So I'm going to multiply everything by 2A, the LCD. So I get 8 plus 4 equals 2A. So A is 6. So since A is 6, then it takes Brent 6 hours. Wait, A is Kent, sorry. So it takes Kent 6 hours, and Brent is twice A, 12 hours working alone. Okay, so the speed of an A&M freight train is 14 miles per hour, less than the speed of the passenger train. The passenger train travels 400 miles in the same time that the freight train travels 330 miles. So this is a distance equals rate times time problem. So usually I write that down first. And I usually make a chart. I got the passenger train and the freight train. And let's see, the passenger train travels 400 miles in the same time that the freight train goes 330. And we want to find the rate for both of these. So the idea, the key here is it says same time. So if I had R times T equals distance, and I know time is t, distance is a number, and I want to solve it for r, what would you do? And hopefully you're saying divide by t. So in my chart here, this is going to be 400 divided by t, and this is going to be 330 divided by t. Now, here, in the first sentence, it says the speed of the freight train, which we know is 330 t from my chart, is, that equals 14 miles per hour less than the speed of the passenger train. So the passenger train minus 14. So you could do it that way. Now, alternatively, I could have set up my chart this way. So there's two ways to do this. So if I set up my chart, passenger, freight, rate times time equals distance. So I could have said, all right, the passenger train, the freight train is 14 miles per hour less than the passenger train. So if we let the passenger train be r, this would be r minus 14. And then the distance would be 400 still. And this one will be 330. And then we can use the same formula, r equals, no, we want to solve for t. T equals d divided by r. 400 divided by r. 330 divided by r minus 14. So instead of using that equation, I could use, here we know the times are equal, says in the same time. So 400r equals 330 over r minus 14. So you can use either of these two equations and you'll solve the equation either way. So I think I'm going to use this one better instead of that one. So let's do it this way. So 400 over r equals 330 over r minus 14, because I want to know what rate is anyway, so it's better just to go straight at it. If I did this equation up here, I would find t, and then I'd have to plug it back in to get both these answers. Alright, so we're going to multiply by the LCD, which is going to be r minus 14. So let's see, the r minus 14's cancel. You get 330 r. Here the r's cancel. And you get 400 times r minus 14. You solve this equation. Distribute the 400. Subtract 330 and add 5600. So that would be 70r. Then divide by 70. So r is 80 miles per hour. That's the rate of the passenger train. Miles per hour, and the freight train so remember the freight train's 14 less, so r minus what is that, 66. So there's your two answers. Okay, Fiona's Boston whaler cruised 45 miles upstream and 45 miles back in a total of 8 hours. And the speed of the river is 3 miles per hour, the current. Find the boat in still water. So, we need to make note that if you're going upstream, your speed relative to the shore is going to be the rate of the boat in still water plus your current. And going downstream, relative to the shoreline is going to be the rate of the boat in still water. Oh, this is backwards. This one should be minus. So if it's going against the stream, it's making you go slower. So upstream it's minus C, downstream it's plus C. Okay? So we're going to set up my chart. We're going to go upstream, downstream. We got rate times time equals distance. So we're going to do that. Upstream is R. R is the speed in still water. So it's R minus 3, because the current's 3. Which in this case is 3. Going downstream would be R plus 3. We did a total time of 8 hours. So if this is 8, if that's T, this is going to be 8 minus T. And then we know the distance is 45 miles. So I got R minus 3 times T equals 45. And I got R plus 3 times 8 minus T equals 45. Actually, the way I'm going to do this is I'm going to solve both of them for T. So instead of doing this way, I'm going to do the 45, the distance divided by rate. And then this one's going to be 45 over R plus 3. And then what do I know about the total time? It's 8 hours, and that's going to be the time 1 plus the time 2. So I'm going to add those two together. So I'm going to take time going upstream plus the time going downstream is going to be equal to my total time of 8 hours. So that's the equation I'm actually going to use. This would have been fine. I would have had a solve a system using two variables. It would get me the same answer, but it might be a little more difficult. This is the way I'm going to do it. So I'm going to multiply by the LCD, which is R plus 3, R minus 3. And remember, when I distribute it, it goes to the top, and so the R minus 3 cancels, and it leaves me the R plus 3. Then I got 45. The R plus 3 cancels, so I got R minus 3. And then on the other side, nothing cancels, so I got R minus 3, R plus 3, which is the LCD. Okay, distribute. So I got 45R plus 135, 45R minus 135 equals 8 R squared minus 9. So I got 90R equals 8R squared minus 72. So quadratic equation, get it equal to 0. Now we'll see this. I want to factor it. So 2 comes out. Now I got to factor that. So let me do that in Scratchwork. So if you want to see, I'm going to do the ridge method. 4 times 36 is 144. Facts 144, that subtracts 245. So 1 and 144, no. 2, 72, no. 3 and 48, that's it. So I'm going to go 4R, 4R, 4. So it's 3 and 48. Bigger ones minus. Signs are different. And then I'm going to factor a 4 out of this one. And that 4 cancels that 4. Nothing comes out of 4 and 3. So 4R plus 3, R minus 12. And I solve it, set them all equal to 0. And so obviously that one won't make sense in context of the problem. So the rate of the boat in still water is 12 miles per hour. And that's what I want to answer, so I don't have to do any other work with it. Alright, so that completes the lesson for 6.5. Go to My Math Lab and complete your exercises there, and I'll see you next time.